On to section 3 of chapter 4, additional exercises, in which we're going to solve these systems of equations by the addition property. Key to all of these is to have them in standard form. So this one is in standard form, but I'll show you even a little better technique. So notice over here they don't quite line up. So I've lined them up nicely. That's the technique. So then you put your line, and then you're assuming that this value of x is the same as this one. That's not always true, but that's what you assume. And notice these now cancel out. So I now get 6y equals a negative 6. So y will equal a negative 1. So we have now one of the coordinates for y, a negative 1. And then we do what we did before. So this would be 2x over here. Now plus y is a negative 1 equals 3. Transpose that, we get 2x equals 4. X equals 2. Now notice this first one you probably could have solved by the substitution method. Just bring this over and put that in there. So this is another method, and again sometimes you have a choice as to what method you're going to use. But when I saw this and that they would cancel out by adding, this is a good example of the addition method. Again, we're not going to do every one, but let's say the odds again. So key to this again is to line them up, and here the x's will cancel out, and we're left with a negative 4y equals 12. So we divide both sides by a negative 4, and we get y equals negative 3. So I was somewhat concerned that I had gotten this, but double checked it, and that is correct. The answer in the answer key is incorrect. And then when I take the negative 3, plug that into the first equation. Keep in mind you have negative and then a negative 3, so this will become a positive. And we transpose that, divide both sides by a negative 4, and this becomes then a positive 9/4. Now the answer they give in the book for number 4 is 8,1. So hopefully these even answers are correct, but again, if you have a question, bring it into Math Lab and we'll work it with you. Now I could have set this up already, but I want you to see it in its sort of basic form. Now notice this is in standard form. This is in standard form, but nothing cancels out like they did before. So here's the case where we now have to start modifying the equations to make them equivalent equations such that something will cancel out when you go to add them together. So what I'm going to do is I'm going to modify equation 1 by multiplying each item by a negative 1. Each item of equation 1 by a negative 1. And what does that do? Well, it changes all the signs. So now I'll have a negative 5x here and a positive 5x. So let's just do that. This becomes a negative 5x minus y equals a minus 2. Now remember, you have to change all of the signs. So this now becomes 5x minus 3y equals 14. Now, the second equation, we don't change anything, because now when we put our line to add them together, these will cancel out, and I'll get a negative 4x equals 12. So now I'm going to divide both sides by a negative 4. I get x equals a negative 3. So there's my first member of my ordered pair. And it looks like I got lost here on the previous. This is y here. So this is our y coordinate, not the x. And you have to be careful and check your work. Now that we have y is a negative 3, I'm using this original first formula, 5x minus 3 equals 2. Transpose the negative 3, that gives me a 5. X equals 1. And that now does check. Again, as you do each of these problems, you're doing many problems. You're solving this to get something that will cancel out. You're adding correctly. You're solving for one letter, and be sure it's the correct letter. And then you are solving for the other letter. So just doing one problem involves, again, many steps, and errors can pop in, so it's good to check your work. And they take time to do. So let's do example 7 now. As we look at the system of equations, they are in standard form, but nothing seems to cancel out. So I see here, and this is the judgment part where you are inputting because you can do different things. But I see here a negative 2y. Here I see a positive y. If this were a 2y, these would cancel out. I can make this second equation a 2y by multiplying each term by 2. Now remember, it's not the same equation anymore, but it is equivalent. So, as I rewrite, notice there I didn't have to change any signs. Just multiply each term by 2. It gave me this. Now, these cancel out, which is what I was looking for. Add this up, I get 11x, 22, x will equal 2. So for number 7, I have x equals 2, and I have the right letter, 2. Now if x is 2, I'll put 2 into, let's say, this first equation. So I'm going to put my x value where x goes in that first equation. This will give me a 10. I'm going to transpose the 10 to the other side, gives me a negative 10. Add it to the 4, gives me a negative 6. Divide both sides by a negative 2, I get y equals 3. And that was the answer they have in the answer key, and this was the answer they gave. Okay, going on to number 9. Now, the help I want to give here is what will be your strategy. So as we look at number 9, well, I want to label the equations. I'm going to say this is equation 1. And this is equation 2. So let's study the equations. They're both in standard form. And it doesn't look like I can do something to either 1 or 2 and be able to cancel something out. But if I look over here, this is a negative 6b. This is a positive 8b. Well, what can I multiply this equation by and this equation by as well so that something here cancels out. Well, I know 6 times 4 is 24, and 8 times 3 is 24. So if I multiply each term in this equation by these, I should get these as 24b, one negative and one positive. Now, I could have done something here. Multiply this one by, let's say, a 4 also, but this one by a negative 3, and these would cancel out. So, again, there's different ways to do it. That's the way I chose. Well, when I did the multiplication carefully here, I ended up with these now canceling out, and I get 24a equals that. So a equals 6. So there's my first coordinate, and since it's an AB variable, it's alphabetical. All right, now what we want to do is put a into equation 1, and I get 3 times 6. 3 times 6 is 18. Notice now I'm going to subtract 18 from both sides. The 18s cancel out, and I'm left with a negative 6b equals 0. Now remember, it's okay for something to equal 0. We're going to solve for b by dividing both sides by a negative 6, or you would know that b is 0. So there's my second ordered pair, and having a 0 there is fine. Remember, this is the x-intercept. And for example 8, it was a negative 2, you don't want to look it up, and a 4. Alright, notice, again, this was a good one where we had to modify both equations to get a solution. And there is lots of work and double checking your work and watching the signs, because there's lots of steps, so it's easy to get an error, and you want to get a good grade on this. Now I'm going to skip some of these. We're going to go on to number 12, because number 12 now is a little different. In fact, if I didn't want to use addition for number 12, you see it would lend itself to substitution very well. But they've asked us to do these by addition. So the key is set it up in standard form. Now here it's going to be x minus y. I bring the y over, and this equals 3. Now you might say, if I add it up the way it is, nothing's going to happen. But if I change these signs by multiplying here everything by a negative 1, this becomes a negative, this becomes a positive, and this becomes a negative. And now look what happens. Here the x's cancel out, the y's cancel out, and I get 0 on this side equals a negative 2. What did we say in the previous lesson when we did something like that? Where what we did is not a true statement anymore. Well, we said for those there was no solution. Now if you were to graph these, you'd see they are parallel lines. So parallel lines have no solution. Remember, if it came out 0 equals 0, which is a true statement, but the letters have all gone, then that would be an infinite number. But here, it's no solution. And the other ones are, for number 10 here is 5, comma, -1, and 11 was 0, comma, -2. Remember, these are an ordered pair, so order is important. Now, as we look at number 13, I think the y should have been up here. So that's an error there. So let me work this one for you. Again, this is in standard form. This is, you need to do some reversing here and fiddle with it. All right, keep in mind there was a typo here. That y should have been up there. And to get rid of fractions, I'm going to multiply this by 2, this one by 2, this one by 2. So here the 2's cancel out. Here I have a negative 2x on this side that I'll bring to the other side, and you say, oh, look what's happening. Yes, these two equations are the same. So I could multiply this by -1 and everything cancels out and I get 0 equals 0, or as we see, they are the same equations. So for number 13, it's an infinite number. And for 14, it's -6, -4. I'm already up to 17 minutes. 15 is a fraction. I hope you don't have one like this, because this is very tedious. 18 over 17 and a -22 over 17. Yes, that would be quite a job. 16 is a -1, -2. (17) is no solution. The lines are parallel. 18 is infinite number of solutions. And let's go on to some word problems. So here we see they give us the two equations. And what I'll choose to do is to change these signs by multiplying every term by a -1. That would make this a negative, this a positive, and this a positive. I now get 5q equals 10. So q equals 2, which you may recall from this is $2. And if I put that back in there, how many pounds of meat will be supplied? I want to put the 2 there, and that is also 2. But keep in mind, this is millions of pounds. Okay, just under 20 minutes, 19 minutes. And again, we want to stress the technique.